All right, so we have enough information to fill this out. First of all, 95% of the students work between 6 and 12 hours per week, and they tell us that this is normally distributed. So between 6 and 12. Right there is going to be our mean. And if 95% fall within 6 and 12 hours, there's our mean. There's our one deviation, standard deviation. Here's our second standard deviation. There's our first standard deviation down, our second standard deviation down. 2.5% out here, 2.5% out here. That leaves all of this as our 95%. 13.5, 34, 34, and 13.5. So given what we're given, this is, so far, our normal curve. What is the mean hours worked? And what is the standard deviation? So the mean is going to be right in between these two. So we're going to do 12 plus 6 divided by 2, which is 18 divided by 2, which is 9. So my mean is 9. And 2 standard deviations above would be a difference of 3. 2 standard deviations below would be a difference of 3. So what number would have to go right here? That's not a 1, that's just a tick. What number would have to go right here? What number is exactly between 9 and 12? 9 plus 12 divided by 2. So 21 divided by 2, 10.5. So this means my standard deviation is 1.5, and another 1.5 would be 3 hours. One standard deviation down would be 7.5. So my mean is 9 hours per week, and my standard deviation is 1.5 hours. Now everything that we're talking about here is only true for data that is normally distributed. In other words, something that you would find in a just sample random data is going to occur normally. So for each of the quantities, decide whether you think it's likely to be normally distributed or not. All right, first of all, the SATs scores of all high school juniors in Texas. All right, so of all the high school students in Texas, would you think the majority, 68%, are going to get in the middle, 95% are going to get basically within the middle, and these would be real outliers? Yeah, I think so. We would think that that would probably be a normal distribution. How about the amount of tax revenue by the United States over the last 60 years? The tax revenue over the last 60 years, how much money the government takes in over 60 years. Do you think over 60 years, the amount of tax the government brings in is going to follow that kind of curve? I think probably no, because you would think that the tax rate increases every few years anyway. I mean, people are not paying the same taxes they paid in the, 1980s. We're making more money and we're paying more in taxes, so it's probably not normally distributed. It's not a naturally occurring phenomenon. There are a ton of outside factors that are going to influence how much money we pay in taxes, so it's probably not normally distributed. How about the length of daylight hours over the course of a year? Okay, so daylight hours like in the winter, Um, like in the winter, our daylight hours, maybe we have 8 hours of daylight. And then in the summer, we might have 15 hours of daylight. Do you think that this is a normal distribution? Well, probably not, because it's cyclical. And it's not going to fall into the length of days is cyclical. So I don't think that that would fall into a normal curve. Probably not. Okay, and how about the amount of time it takes students in class to finish a given homework assignment without a time limit? Do you think most of the students will fall within a certain time limit, and just some people that really know the material, they'll get done quickly, and some people that are struggling, they'll work slowly? But the basic, most of the students in the class, the majority of the class, will fall into this normal distribution? I'm guessing yes. Now, all of these are opinion questions. We're just trying to think of a normal distribution and what you would expect in a normal distribution curve.